Jai Hind. Today we'll talk about Bayesian classification. In this particular lecture, we'll talk about the Bayes theorem. We'll start with how the Bayes theorem is used in calculation of conditional probability calculation. Then we will talk about Bayes optimal classifier, and then we will add on an assumption to discuss the naive Bayes classifier with an example. So let us start the topic with Bayes theorem. The probability is the calculation of the chances of happening an event. When we are calculating something and no other information is given before that, that is our prior probability. For example, if I say that we have the pH prior probability of hypothesis H. What is hypothesis H? This is some way of occurring of the events in surrounding. So that is our hypothesis. We will calculate the prior probability of any hypothesis according to our experience. What does it mean? It means we are having observations of the working domain, and based on that we have come to know that this is the probability that this hypothesis will be true. So that is prior probability. Same way we can have the prior probability discussion observation of the data, that what type of data we observe, that is the prior probability. Now what we talk about in Bayes theorem, that is conditional probability. What is conditional probability? If I am having an event A and it happens after the occurrence of another event B. Okay, so what it is? It is probability of A when B has happened. So now if A and B are conditional independent, if A and B are totally independent, in that case B occurrence will not affect the probability of A. But if these are not independent events, then occurrence of B will affect occurrence of A. We can take an example that if we are having an umbrella, so there is some chances of carrying umbrella. But if it is raining, if it is given that it is raining, let me say B is the event that it is raining, in that case the probability of carrying an umbrella increases. So the rain is affecting the occurrence of chances of A event. A is carrying umbrella and B is the rain. Okay, so this is conditional probability. What does Bayes theorem says? Bayes theorem says that the probability of occurrence of hypothesis H when B is the observation, that is the training data. When observed data is there, what is the probability of H? That is equal to probability of observation when H is the hypothesis into prior probability of hypothesis divided by probability of D, the observation. This is the prior probability of training data. Okay, so now what we are calculating? We are calculating the probability of hypothesis given the observed data. This is conditional probability. So this conditional probability can be calculated with the help of Bayes theorem. Okay, so now what we call it? When we have some observation and the probability of hypothesis, that is called posterior probability. When we are talking about probability of hypothesis from experience, that is prior probability. So we take this concept of posterior probability of hypothesis given the observed data in classification. What else we use in different calculation of the classification? One is product rule. These are general basic rules of probability that we use along with our Bayes theorem. Probability of A and B. What does it mean? It is conjunction of events of A and B, that is equal to probability of B into probability of B when A has happened. Or it can be probability of A into probability of B when A has happened. What is disjunction of two events? That is our sum rule. Probability of A or B. What is probability of A or B? It means probability of occurrence of A or B. So it will contain probability of A plus probability of B minus the chances which are included in both A as well as B. That has been added twice, so one occurrence will be deleted. This is the sum rule. Now, what is the theorem of total probability? If we are having more events than 2, probability events, the events we are taking here for which we are calculating the probability, total probability, the events are A1, A2, An. So, the total probability when these events are mutually exclusive, then what we will have, probability of B is equal to I is equal to 1 to n, means summation of all the probabilities of probability of occurrence of A1 event into probability of occurrence of B when A1 has happened plus probability of occurrence of A2 into probability of B when A2 has happened, and so on. Total events that are occurring here are n. So, these are some general formulas that we use for calculation. Now, we will talk about the Bayesian classification. So, when we have the Bayes theorem, there are multiple hypothesis way that we can use to calculate the classification result, that what will be the probable class for the given data. So, we are given data D that we are considering here. So, one way is to do this that we generally use, that is most probable hypothesis. What is most probable hypothesis? That we call map, H map. What will be H map? H map means we will take that class which is having the most maximum posterior. So, it is MAP, maximum a posterior. What we will do, let me say I am having two classes. So, I will have hypothesis 1 that the instance belong to first class, the hypothesis H2 says that it belongs to second class, class 2. So, what we will calculate? We will calculate probability of H1 when D is the observation and probability of H2 when D is the observation. We have taken two hypotheses here. So, what we will find out, two hypotheses, because we are considering there are two classes. So, we will calculate posterior for H1 hypothesis as well as posterior for H2 hypothesis. From these, we will consider the maximum one. The instance will belong to that which is having the maximum posterior. This is called map, maximum a posterior. Now, what happens in all the cases? The H map is not most probable classification. In many cases, it is giving us very good result and we can take it as the most probable classification. But there may be the cases that when we do not find, or in domain actually the H map is not the most probable classification. So, how do we understand? We will discuss this with an example. Let me consider here that I am not having two hypotheses, mean two classes. I am having three classes, class 1, class 2 and class 3. My first hypothesis will be that the instance belongs to class 1. The second hypothesis will be it belongs to class 2. Third, H3 is it belongs to class 3. So, let me consider I am having these posterior probabilities. What are these posterior probabilities? Probability of H1 when D is the observation is, let me say, 0.4. Probability of H2 0.3. Probability of H3 that it belongs to third class, it is 0.3. Now, what is maximum a posterior? So, for H1 we are having the maximum value. So, according to map algorithm, map method, maximum a posterior, it should be H1, that the instance must belong to class 1. But if we see it overall, what we are finding by overall observation, that it is only 40% chance that it belongs to H1. And 0.3 plus 0.3 means 60% chances are that it doesn't belong to H1. So if this type of cases are there, then H map is not the most probable classification, because only 40% examples are in favor and 60% are saying no. Okay, so it is not the most probable. So in that case, what we have, we will have a change in the calculation. What is that? The probability of the class when the observation is given should be weighted. Now what will be the weight? The most probable classification of the new instance is obtained by combining the predictions of all hypotheses, because it may be the case that when we combine the results of hypothesis, as we have seen in the previous example, when we combined all the results, we found that 60% are against the rule of belonging to class 1. Okay, so we will combine the prediction of all hypotheses weighted by their posterior probabilities. So what is the posterior probability? That is probability of H1 when D is there, probability of H2 when D is there. So what we will have, it belongs to class 1 when hypothesis is H1, and this is multiplied with the posterior probability. If the possible classification of the new example can take on any value Vj from some set V, so we are having a set V and we have to find out the classification from V1, V2, V3, whatever data is given, then the probability Vjd that the correct classification for the new instance is Vj. Okay, what we will find out? We will find out the optimal classification of the new instance is the value Vj, for which Vj when D is there is maximum, not posterior. We have calculated the values of the classes. In that, we calculated it with weight of posterior probability. So what this method we call, it is Bayes optimal classifier. So rather than only calculating the maximum a posterior, what we will calculate? We will calculate the probability of possible class weighted with the posterior probability, and we'll take sum of these. We'll combine the probability of all the hypotheses. That is what our concept is. The new instance is obtained by combining the prediction of all hypotheses. In that case, we were calculating the probabilities which are posterior probabilities, and we were just considering which is having the maximum value. Now what we are saying, that we will combine the probability of all the predictions. All the predictions we will combine, and every prediction will be given the weight. And what will be the weight? The posterior probability. So this is our formula. We will find out the maximum of the predictions weighted by the posterior probability. Prediction will take, and we will take the posterior probability. So now let us take the example. So what is probability of H1 when D is there? We have taken 0.4. H2 when D is there, 0.3 we have taken. Probability of hypothesis H3 when D is the observation is 0.3. Okay, so what does it says? What is the prediction here? It predicts that H1, the probability is 0.4. So what it says? It says that the probability that it belongs to H1 positive class is 1, because it is giving that it belongs to positive class. Let us go back. We are having two classes, positive class and negative class. H1 was saying that it belongs to positive class. H2 was saying that it belongs to negative class. So 40% were saying, the posterior probability of H1 was saying that it is having the positive class, but other two in combination were saying that it doesn't belong to this class, it belongs to negative class. So what it is saying that it is belonging to positive, what other two are saying that it is belonging to negative class. So positive class probability when H1 is there is 1, and what it is saying, the second hypothesis posterior is 0.3, and what it is saying that it belongs to negative class. It doesn't belong to the class which is taken by H1. So it is saying that it belongs to positive class, negative class. So probability of positive class is 0. It is also saying that it belongs to negative class. So probability is 1. So now we will consider all the calculations. Now what are the calculation? Vj now is V1 and V2. V1 is positive class, V2 is negative class. So it is saying that 0.4 is the probability for positive. So we are combining all the probabilities of positive predictions. What are probability for positive predictions? 0.4 into 1 plus 0.3 into 0 plus 0.3 into 0. So it is 0.4 only. Now what is the combined probability prediction for combined predictions for our negative class? By given multiplied by the posterior probabilities, that is 0.3 and 0.3. So negative, what is chance of probability this H1, that is 0.4 into 0. It doesn't say that it belongs to negative class. So 0.4 into 0 plus 0.3 into 1 plus 0.3 into 1. So in combination it has become 0.6, because these two are saying that it is in negative class. So if we see this, what we are getting here? We are getting that the maximum weighted value, what we have to take the weighted value, maximum weighted value is 0.6. Okay, so from here what we will observe, what will be predicted, that it belongs to negative class. What we were doing in the map, we were simply calculating the hypothesis values for all the posterior probabilities for hypothesis, and we were taking H1, that we were taking that it belongs to positive class, just because probability, the posterior probability was higher for H1 because it was 0.4 and it was 0.3 for H2 and H3 both. Now what we have done, we have calculated the predictions based on all the combinations of the predictions weighted by the posterior probability, that is our Bayes optimal classifier. Now to be noted, it is very good method. It is it always gives us optimal solution. But what is the disadvantage of Bayesian optimal classifier? By the name it is clear that it gives us the optimal result, the best result. Now what is the problem? Problem is the computation is too much inefficient. No other method can outperform this. This is the optimal classifier. There is no other method which are using the same hypothesis space and same prior knowledge. No method is there which is using the same space and knowledge and can outperform it. But what is the problem? The problem is the calculation complexity. The computing is hopelessly inefficient. There is another method that we do using Bayes theorem, that is Gibbs classifier. What is there in Gibbs classifier? We know that Bayes optimal classifier provides us the best result, but what is the problem? The computational complexity. So it is expensive if we are having many hypotheses, because for each hypothesis we have to calculate the posterior probability, and then we have to take the prediction, and the prediction will be weighted by the will be multiplied by the posteriors as weight, and then all will be combined, and then the combined result will tell that which is having the maximum value of the combined result, that will be the given class, that will be the predicted class. So we can have another method, that is Gibbs algorithm. we actually want to avoid the computational complexity of the Bayes optimal classifier. What Gibbs algorithm says, it says that choose one hypothesis at random. We are given posterior probabilities. Now, according to posterior probability, we will select at random. So, let me say we are having the probability, let me say 0.4. So, 40% is the chances of random selection of this particular hypothesis, and we will classify the new instance using that randomly selected hypothesis. According to that, it will be. So, this is one of the other methods which are used. And what is the main, why we consider it? That is the surprising fact that we have. Assume target concepts are drawn at random from H according to priors. If we will select any randomly from the hypothesis space and we know only the prior probabilities, then what is the random selection power? The error given by Gibbs classifier is less than equal to twice the error given by the Bayes optimal methods. Whatever we will have error using Bayes optimal, this will be just maximum, the difference is twice that. It cannot be more than that. Okay. So, this is also one option. We can use Gibbs classifier if we can avoid, we can bear the suboptimal solution. In maximum, it can give us just twice the error of the twice the error given by the Bayes optimal method. And now, as we are having the too much calculation complexity in Bayes optimal classifier, there is another option that we can use, and it has been successfully applied to number of application, including diagnosis of different diseases, classification of different text documents. Now, the question is, when do we use naive Bayes classifier in place of Bayes optimal classifier? When we have large training data set available and the attributes that describes instances are conditionally independent given the classification. If the classification is given, then the instances which are described by their attributes, these attributes are conditionally independent. When we take this assumption, we can assume that all the attributes are conditionally independent given the classification, then the calculation complexity of the Bayes optimal method can be reduced, because in this we will not use chain rule then, because all are conditionally independent given the classification. So, if we know the classification probability, we will simply take the probability of attribute when the classification is given, and classification probability we are able to calculate. So, what we have in this, this we have already discussed that what is map? Map is the maximum probability, maximum posterior. Okay. Now, what naive Bayes says? Naive Bayes says that A1, A2, AN all are conditionally independent. Because all are conditionally independent given the VJ, the class, then rather than doing this calculation using chain rule, we can simply say that it is the product of probability of AI when VJ is given into probability of A2 when VJ is there, and so on. Why? Because these are conditionally independent. Okay. So, this chain rule calculation can be highly reduced. The complexity can be highly reduced by taking the naive Bayes assumption of conditional independence of all the attributes when the class is known, when the classification is given VJ. So, what we will find out here in naive Bayes classifier, this is VNB. What we find out in NV, we find out this independent calculation for each of the class, and we will consider that class in which it is giving us the maximum value. Let us try to understand it with an example. So, this I have taken as the example. For each value, I will calculate Vj, that is the posterior probability, and then for this posterior probability, I will estimate probability, I will calculate the prior probability, and for this prior probability, I will calculate probability of each attribute given the Vj, the class. Okay, and then we will find out maximum as we discussed on the last slide. So, what we are having here, this is our example. In this example, I am having the class as yes class or no, positive class or negative class. If I calculate here the class is y, that is yes and no, negative class. So, probability of y, this is the prior probability that we can calculate from the experience. What experience we are having? We are having that in these cases it is no. So, how many cases I am getting for no? 1, 2, 3, 4, 5. How many total are there? 14. So, no probability is 5 by 14, that is prior probability. Okay. And now if I say yes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 by 14 is my probability that it belongs to positive class. Okay. So, this is our prior probability. Now, this we have. Now, what is the question? That depends what actually we want to calculate. We want to calculate the answer will be positive class, that is y, or negative class n, when outlook is given sunny, temperature is cool, humidity is high and wind is strong. So, this combination is given. So, we have to calculate the probability of class. It will be belonging to positive class or negative class. We have just calculated that probability of y is 9 by 14 and probability of n is 5 by 14. Now, what we have to check? Outlook is sunny. Okay. So, outlook is sunny. Now, we are given the class y. So, we will simply check. These are all the attributes are conditionally independent when the class is given. Class is given as y. So, what is the first attribute? Outlook. Its value is sunny. So, what is the probability of sunny when it is y? What is the probability of all the favorable cases of y? That is 9. Now, what we will calculate from here? Sunny in case of 9 cases of yes. These are yes, yes, yes. So, how many are sunny here? 1, 2, 2 I am getting. 1 is this, 1, 2, and these 2 are negative. So, it is 2 by 9. It is 2 by 9. Same way we will find out when it is yes, then how many are cool? Temp is cool. So, temp is cool in this case 1, 2, 3. It is 3 by 9. So, we have taken all the attributes independent of one another when the classification is given, and classification we have considered as yes or no. Okay, so we are considering it for yes class. So, in case of yes, how many are sunny, that we calculated, how many are cool, that we calculated, that is the posterior probability. Same we will do for high. When it is y, when the probability is y, then how many are, what is given? Humidity high. So, in yes, 2 high instances, 1 more high. So, it is 3 by 9. 3 by 9 again. Okay, then we will check for y the wind. Wind is strong. Wind is strong. Okay, so for yes it is weak, 1, 2, 3. It is also 3 by 9. 3 by 9. So this way we calculate the positive probability. Same way we will calculate the negative probability. If I take sunny in case of no. Sunny in case of no. No is there. So 2 are sunny. Then no is there. No, again 3. 3. So it is 3 by 5. Out of 5, 3 is sunny. So we will calculate both the probabilities when the class is given. Okay. So now finally we will calculate it and we will take the maximum value which are found. So for these calculation we are finding the value for negative more. Okay. So what will be predicted, that is negative class, because by calculating this independent conditional independent theory with the help of given class, we are getting more value for negative class. So it will be predicted as negative. So this is our naive Bayes method. It is based on our Bayes theorem. What we have discussed in this particular lecture, that is Bayes optimal classifier, Gibbs classifier, that is also a very much good comparable with Bayes when we use randomness, and then naive Bayes when we have the conditional independent theory. Thank you. Jai Hind.